Hello. Hi, this is Xiaoyu. I'm from assetbacked.org. Today I'm going to go through a new feature that implemented in absbox and Hastructure. It's called term-based asset performance assumptions. So a little bit background why I'm going to bring up this feature. Um, Traditionally, in the very classic cash flow projection for structured finance or a pool of assets, there's two metrics we were using, the prepayment vector or default vector. Typically, it's a CDR and a CPR. Either we can apply a single value, like the 7% of the CDR, to the whole bunch of assets in the pool, or to model the future fluctuation on the default behavior of the assets, we may apply a default curve or CPR curve. So that's we're gonna stress the performance of the pool. Once the assumption was applied, typically a cash flow engine will project the pool cash flow based on these two assumptions. So what's wrong with that? Or CDR and CPR, why they are not good enough? Let's let's take this for an example. For example, I have a, a large pool of mortgages, but all these mortgages are not vary in different uh, vintage. Some of them are recently issued, has a very long maturity, and some of them may have um, already aged for 2, 3, 5, 6 years. So different mortgage in ages, they may present different pattern on prepayment behaviors. For example, typically in the first 5 years, the prepayment rate of the mortgage is pretty low. And for the mortgage already aged for 5 years or 10 years, the prepayment rate could be very high. So different age of the mortgage, they present different prepayment rate or prepayment pattern. But when we cluster them into a single pool and project them cash flow with a single value or single curve value, that may create some inconsistency. For example, here we apply 7% on the pool level, but for mortgage with just recently issued or originated, the 7% of the prepayment is fairly high value. So that's the bad things about when we pool a lot of assets with different ages into a single pool and we apply with a CPR, either a single value or a curve. That may mismatch the pattern of the prepayments because of the variety of the ages of the mortgage. Same story. On the other side, for example, if I have installment type assets, the default pattern really presents differently. For example, at the very beginning, when the installment assets was issued, typically the borrower has a good credit. So it's less likely he or she will default it. So the default rates at the very beginning for a couple periods are fairly low. But when the credibility of the borrower deteriorates, so in the later or close to the final payment, the default rate could be very higher. So the default rate pattern for the installments or even for mortgages is typically very low at the very first or on early stages, and the default rate will surge in the after the middle or to the maturities. So that's the typical pattern of the default rate is period-based. So here's the question. If the CPR and the CDR curves projecting from the pool is not accurate, and we are easily to build, or we can, based on statistics, the originator are easier to build curves based on the period-based performance curve, like the default rate or prepayment. What about we can build a term-based assumptions in the cash flow engine? Won't that be very nice? We can model the prepayment defaults based on the term of each individual assets. How that would work in absbox and the Hastructure. Here, user need to input with a two-dimensional vectors. For example, the first vector, the length is 3. The second vector, the length is 4. So if asset with original term equals to 3 and remaining term of the asset is 2, then the engine will match by asset's original term to look up the performance vector here, 3, because it equals to the original term. Then, because of the remaining term of the asset is 2, so the engine will truncate the vector and use last 2 periods as a performance vector. By current design, absbox and Hastructure support both ways. Use this mechanism applies to a CDR and a CPR as well. Let's pick up the example here. If I have a mortgage assets, it has original term 18. And I supply with multiple vectors here. There are 3 types of vectors. The first one, the length is 18. The second one, the length is 12. The third one is for the mortgage with length of 6. So in current mortgage, it's 18. Then the engine will pick up the first vector. And then it will look up the remaining term is 12. So the engine will use the vector of the first and truncate first 6 elements from that vector. So the rest of the 12 will be used to project the cash flows. In here, the first 3 is 1%. Here, you can see that in here, the first period of cash flow, the first default amount is 100. It's 1% of the beginning balance. At the first period, the default rates surge up to 2%. In here, the default amounts equals to 2% multiply the beginning balance here. So in typically, this is a fairly good example to demonstrate how the engine will apply term-based assumptions on the defaults. So how about the prepayments? In the syntax of absbox Hastructure is fairly easy because in the last one, it's in the first position that's what's being used for default assumptions. And the second position that will be used for prepayments. In this example, we just move the curve to the second spot, then the vector will be applied as a prepayment rate here. So how we can, let's make it further, how we can make the assumptions more fine or more accurate. We can combine with other mechanism that adopted by the absbox Hastructure. For example, we can use the tag-based selection combined with term-based assumptions mechanism. In here, we build a term-based vector, and we built a typical CDR-based, very traditional classical way of the default rate assumptions. So we have two assumptions. Then we can, based on the tags or the attributes of the assets, we can dispatch the assets to different assumptions. In here, you can see, okay, I'm going to use tag-based mechanism to dispatch the assumptions to different assets. The first row, what it does said is, for the assets with a credit level in A and the age of the borrower is less than 35, it will use the assumptions called PPY assumption. So that's term-based prepayment assumptions. For the rest of the assets that missing by the criteria here will be used default assumptions here. So let's go to see what's happening. In here, we first model two assets, and for these two assets, we need to model the tag, the fields, so the engine will look up to test on these criteria. Then once we run it, we are able to see that the cash flow, that both assets has been applied. The first assets will be applied with the prepayment. The second asset will be applied with the default. So when the cash flow aggregate together, we are able to tell that both prepayment and default cash flows. Okay. In this way, we can have a very fine or small granular capability to assign the different assumptions to a pool with a lot of assets. So that was aimed to increase the accuracy of the cash flow projections. This feature was introduced by 24.6. So if you install the package from absbox and Hastructure after 24.6, you are able to use that feature. Okay, so that's pretty much it. If you are interested in absbox or Hastructure, you are welcome to view the documents in online. Meanwhile, I'm providing the commercial support with the enterprise integration, which basically putting the Hastructure engine into the company who might be interested in it.